All right, so today we are going to be talking about our weather products. So last week we talked about how to read weather, or I'm sorry, how to interpret weather, what causes weather. This week we're going to look at actually interpreting the different ways that weather is communicated to us. So the first thing, the most common thing you're going to see um, when it comes to interpreting weather are what's called METARs, or otherwise known as aviation routine weather reports. So what this is it's an observation of surface weather reported in a standard format. So every METAR is going to follow the same format, and it's all going to be written in the same sort of shorthand, which we're going to go over right now. So the first thing you're going to see, number one here, is going to be the type of the report. So it can either be a normal report, in which case it'll say METAR, or sometimes it won't even have anything in front of it. Just will totally omit this section. Or it'll say SPECI. So if there is the need for a special report or an update to the METAR that is not made at the regular time interval, it will be known or it'll be notated as a SPECI or special report. So a lot of airports only update their METAR once an hour. But if there's a significant change in weather, they will update it when they need to, and that'll be a special report. The next thing you're going to see, number two here, is going to be the four-letter ICAO code for the station. So the airports in the lower 48 of the United States are all going to start with a K. So this right here is KBNA, or that's Nashville. Once you get outside the lower 48, if you go to Alaska or Hawaii, they start with a P, and then Canada starts with C's, and Mexico starts with M's. Europe's all over the place. I think they start with E and other things, but in the States, it'll be a K. Next, number three, it's going to be the day and the time. So it's always going to be two numbers for the day of the month and then the four numbers for the time in Zulu. So right here, we're looking at the 28th day of the month at 12:51 Zulu time. So remember, Zulu is Greenwich Mean Time. So for us here in Central Ohio, that's going to be either Zulu minus 4 hours or Zulu minus 5 hours, depending on if it's daylight savings or not. So this for us would be 12:51 Zulu would be about 8:51 local time in the morning for us. Okay. So it's 28th day of the month at 12:51 Zulu. Um, Right here, we have what's called the modifier. So number four here is the modifier. If it says auto, the report came from an automated station. If this is omitted, if auto is not in there, then it came from a station that is monitored by a human. So like at Delaware, Delaware doesn't have a tower and just has a computer that continuously updates the METAR. Okay, so it'll say auto at Delaware, but like at Ohio State, where they have a tower, it won't say auto because there's a human that will look at the information that's being reported from the uh, weather gathering system before they release the METAR. So it will not say auto there. Moving on, though, number five, we have the wind. The wind is always going to be reported in 5 digits or more. We'll look at a case later where that could be the situation. But the first 3 digits indicate the true wind direction. So it's reference to true north. Okay, the written likes to ask about that. If the wind is reported in true or magnetic, and it's reported in true wind direction. They do it in 10-degree intervals. Then the last two numbers indicate the wind speed in knots. So right here we see 120. So the direction is 120 degrees at 8 knots. So 120 at 0.8 knots. If you have calm winds, you'll see 0000. That means that there is no wind. Next, we have the visibility. So this is given to you in the prevailing visibility, which means the greatest distance the observer can see and identify objects through, at least half of the horizon. So here, number six, we're looking at 4 statute miles visibility. So 4 statute miles visibility is going to be your prevailing visibility. When visibility varies greatly, the observer can report individual sectors in the remark section. So down here, when we get to the remark section, they could say, runway 25 left, uh, quarter mile visibility, something like that. Sometimes when the viz gets down so low, you'll see RVR, which stands for runway visual range. And then they'll give you like 1/4 or RVR 2,500, and that's giving you either in quarter mile or 2,500 feet. Okay. Next, so let's go back to this for a second. Number 7, you can see right here. Next, you're going to have what the weather is. So if there's actual weather phenomenon occurring at the airport and being detected, that's what you're going to have here, number 7. So right here, what we're seeing is a minus sign and then RA and HZ. So you can have a qualifier in front of your different types of precipitation. You'll either have a minus sign, a plus sign, or no qualifier. A minus sign means light, a plus sign means heavy, and no qualifier means moderate. So in this case, we're observing light rain with some haze. Okay. Next here on this page, you can take a second, pause, take a picture of this, look over it. These are the different qualifiers and descriptors that can be found in the METAR. You're going to need to know most of these. Actually, not most, but you need to know a few of them. Okay, the most important ones to know are going to be you need to know the qualifiers. So light, no qualifier, heavy, and vicinity, VC. So vicinity stands for, or VC stands for vicinity. You also need to know thunderstorm, which is TS, freezing, which is FZ. You'll need to know rain, snow. Um, you need to know mist or BR, baby rain. That's what people say. Baby rain is mist. You need to know fog. Those are the most important ones, and haze. Okay. Make sure you at least have those down, and it's good if you know the other ones. Okay, so moving on. After 7, we'll get to 8, which is going to be our sky condition. So this list heights, it lists the height and in some cases the type of clouds, and it's always in AGL or above ground level. Okay. You have 4 different types of layers that can be reported. You can have scattered, broken, overcast, and few. And automated stations only detect clouds up to 12,000 feet. So if there are no clouds below 12,000 feet, it'll say clear. Okay, you don't need to know these by heart, but few cloud coverage is when the clouds cover less than 2/8 of the sky or a quarter of the sky. Scattered is between 3/8 and 4/8. Broken is 5/8 to 7/8, and then overcast is anything greater than that. There are some suffixes that you may see with these that you need to know. So CB stands for cumulus nimbus. So if you see OVC 023 CB, that means you have overcast clouds at 2,300 feet cumulonimbus, and they're cumulonimbus clouds. If you see TCU, that's towering cumulonimbus, that's even worse. So that's like a towering thunderstorm cloud. Sometimes you'll see the designation vertical visibility. What that means is that the clouds are so low that the equipment is just measuring how far up it can see. So usually you'll see vertical visibility like 200 feet, 300 feet, 400 feet. So that's when you have like low fog, low visibility. The secret to reading these right here is going to be you're always going to add 2 zeros onto the end of this number, no matter what. So in this case, we have broken at 1,000 feet above ground level. Over here, we have overcast at 2,300 feet uh, above ground level. So if this one was actually here, it would be broken at 10,000 because we'd add 2 zeros onto the end of it. If the one was in the third digit, then it would be broken at 100 because you'd add 2 digits onto the end of that. Ceiling. So a ceiling is considered broken or overcast clouds. If you have scattered or few, that's not considered a ceiling. So if you have a scattered layer at 500, that's not a ceiling. But if you have a broken layer at 500, that is considered a ceiling. Next, number 9 here, we have temperature and dew point. These are always going to be reported in Celsius. So right here, our temperature is 21 and our dew point is 17 degrees. Remember from last week, the dew point is the temperature at which the air must be cooled to become fully saturated. If the temps are below 0, you'll have an M in front of these numbers. So you'd have M21, M17. That would be minus 21 and minus 17. Number 10 is going to be our altimeter here. So A3005 is giving us our altimeter setting. So the altimeter is going to be 30.05 inches of mercury. And the last thing we'll see here is number 11, the remarks. So these are used to relay any additional information. So you can find all sorts of goodies in here. The most common ones you're going to see are going to be AO2, which is telling you that this specific METAR station has precipitation discrimination abilities, meaning that it can discriminate between types of precipitation. Like, is it raining? Is it sleeting? Is it hail? If it says AO2, the station is capable of that. If it says AO1, then it is not capable of that. It can just tell you if there's precipitation. The money sign at the end of this remarks section means the station requires maintenance. Okay. Remarks RAB, in this case, RAB 25 means rain began at 25 minutes past the hour. Um, all these crazy things you're going to see that you can see in the remarks, you're not expected to know, but you are expected to be able to find what they mean. And the easiest way to do that is to go to chapter 7 in your AIM, in your FAR AIM, the safety of flight chapter, and you'll find there is a key for the METARs. It goes through everything that can be in the METAR and explains it to you. So you'll have to go to that to find out anything you have a question on. So we're going to practice reading some METARs here. So what we're looking at is KDLZ. So that's going to be the airport on the second day of the month at 12:35 Zulu. This is an automatic report. The wind is from 210 at 4 knots. The visibility is 10 statute miles. The sky is clear, so there's no clouds. The temperature is 13 Celsius. The dew point is 7 Celsius. The altimeter is 3008. Our remarks section says AO2, meaning this station has precipitation discrimination. Next one here. So this is KCMH on the second day of the month at 12:51 Zulu. The wind is 180 at 4 knots, 10 statute miles. We have few clouds at 25,000 feet. The temperature is 14. The dew point is 6. Our altimeter setting is 3008. Our remark section says AO2, so this station can discriminate between types of precipitation. And then for towered airports, you are normally going to see these two things in the remark section. What this is, so SLP stands for sea level pressure. So this is your sea level pressure given to you in millibars instead of inches of mercury. So the sea level pressure in this case is 1018.5. So always put 10 out in front of this. You never need this information. I don't know why it is in the METAR. What I guess is that some larger aircraft, like jets and such, need this information for performance calculations. This next thing right here is going to be your exact temperature and exact dew point. So the exact temperature right now is 13.9 degrees, and the exact dew point is 6.1 degrees. So here we have a METAR from Lunken down in Cincinnati. So try to read this one real quick. So pause the video and try to read it, and then we'll decode it together. Okay, so this is second day of the month at 12:53 Zulu. Calm winds, 4 statute miles. BR stands for baby rain or mist. So mist scattered at 200 feet. The temperature is 12. The dew point's 11. Altimeter setting is 3008. Remarks are telling us AO2, precipitation discrimination. Our sea level pressure is 1018.6. And our temperature exactly is 11.7. And our dew point exactly is 10.6. Once again, try to read this one real quick, and then we'll go over it. Okay, so this is a METAR at VVG, second day of the month, 12:55 Zulu, automated report. Wind is 320 at 4 knots, 4 statute miles, mist, overcast at 600, temp is 11, dew point is 11, altimeter setting is 299 or 6. Remarks, AO2, so it has precipitation discrimination. And then here we've got visibility 2 1/4 of a mile for runway 12, 30. This CLG stands for ceiling 100 on runway 12. Then we've got sea level pressure 1014.8. Our exact temperature is 11.3. Exact dew point is 11. TSNO. So you're going to have to look this up in your FAR aim, but I'm pretty sure that this stands for thunderstorms north. And then remember the money sign. Money sign means it needs maintenance. Next, we're going to talk about the TAF. So the TAF is the Terminal Aerodrome Forecast. What this is basically is it's in the same language as our METAR, but it's a forecast instead of an observed weather phenomenon. So TAFs are usually good for 24 hours. They can be good for 36 hours. They're released 4 times a day and in 6-hour intervals. Not every airport is going to have a TAF. Okay. Mainly just towered airports, but some untowered airports do have TAFs. Columbus has a TAF, Cincy has a TAF, Ohio State does not have a TAF. Rickenbacker has a TAF. Findlay is an untowered airport, but they have a TAF. Delaware does not. Reading a TAF is pretty much the same as reading a METAR, with one caveat. So it'll say TAF, that's going to tell you that it's a TAF and not a METAR. It's going to have the date that this was released, so the fifth day of the month at 1740 Zulu. This right here, number 2, is going to be your valid period. So this one is valid from the fifth day at 1800 to the sixth day at 1800. Then it has the current weather conditions. Variable at 4 knots, plus 6 statute miles. So this right here, P6SM. In the TAF, they are never going to give you 10 statute miles visibility. They're never going to give you anything more than 6 statute miles visibility. If they are forecasting it to be greater than 6 statute miles visibility, they will just put P6SM. Next, we have the weather condition. What we're seeing here is VCSH, or vicinity showers. Then we have a scattered layer at 4,500 feet, a broken layer at 12,000 feet, and a broken layer at 25,000 feet. Here's the main difference for the TAF. What you'll see here is from, so FM stands for from. So from the fifth day at 1900, you're going to see variable at 4 knots, plus 6 statute miles, vicinity thunderstorms, broken at 5,000, cumulonimbus clouds, broken at 12,000, broken at 25,000. They're expecting this weather until the next from period, which is from the sixth day at 300 Zulu, 220 degrees at 3 knots, plus 6 statute miles visibility, scattered at 6,000, broken 12,000, and broken 25,000. So the main difference between this and the METAR is just these going to be these from periods. So let's read a couple here. So this one's from the second day of the month at 11:22 Zulu. The valid period is going to be the second day of the month to 12 Zulu on the third day of the month to 12 Zulu. Variable at 3 knots, plus 6 statute miles, and scattered 25,000. Then on the second day of the month at 1600, they are forecasting the wind from 240 at 5 knots, plus 6 statute miles visibility, scattered 25,000. Then from the third day of the month at 400 Zulu, 160 at 4 knots, plus 6 statute miles visibility, and few 25,000. Try to read this next one down here, and then we'll go over it together. Okay, so this one is the second day of the month at 11:37 Zulu. It's good from the second day of the month at noon to the third day of the month at 1200 Zulu. Right now, the wind is 260 at 5 knots, plus 6 statute miles visibility, scattered 3,000, scattered 25,000. Starting at the second day of the month at 1700 Zulu, you'll have the wind at 150 degrees at 7 knots, plus 6 statute miles visibility. VCTS, remember, vicinity thunderstorms broken, with clouds broken at 3,500 feet cumulonimbus. Then they are forecasting temporarily from the second day of the month at uh, 20 Zulu to the second day of the month at 24 Zulu. They're forecasting variable winds, 15 knots, gusting 25 knots. So the wind will be 15 knots, gusting 25 from a variable direction with 2 statute miles of visibility, thunderstorms and rain, and broken 2,500 cumulonimbus clouds. Then they're forecasting on the third day of the month at 100 Zulu. The wind will be 160 at 5 knots, 6 statute miles, light rain, overcast at 3,500 until 700 Zulu, when it will become variable knots. Or, I'm sorry, variable at 4 knots plus 6 statute miles visibility. Vicinity showers, scattered 2,500 and broken 25,000. One more, try to read this one, and then we'll go over it. All right, so it's second day of the month, 11:20 Zulu. Um, it's valid from the second day of the month at 1200 Zulu to the third day of the month at 1800 Zulu. So this one's good for 36 hours. Wind is 180 at 4, 6 statute miles visibility plus 6 statute miles visibility. Scattered 1000 temporarily on the second day of the month from 12 to 1500 hours. They're forecasting broken at 1000. Then on the second day of the month at 1600, they forecast the wind to be 160, 13, gusting 21, plus 6 statute miles visibility, few 4,500. On the third day of the month at 200 Zulu, 160 at 10 knots, plus 6 statute miles visibility, few at 6,000, scattered 25,000. 800 Zulu on the third day of the month, 170 at 7 knots, plus 6 statute miles visibility, broken 1,300. And then finally, the third day of the month, 1,500 Zulu, 160, 11 knots, plus 6 statute miles visibility, scattered 3,500. All right, next we'll talk about pilot reports or PIREPs. These are reports made, that says my, but means by pilots in flight to ATC or flight service. They usually report conditions like cloud bases and tops, icing, turbulence, etc. And another typo here. You should make a PIREP whenever you encounter unforecasted weather conditions. Okay. Um, Usually, PIREPs are going to be regarding things that are hard or impossible to forecast. ATC, making a PIREP can be as easy as ATC asking you how your ride is, and you tell them, light chop, or you tell them smooth, and then ATC will go in and input the rest of the information to make a PIREP for you. So a PIREP is going to contain the same information every time, just like a METAR. If you look over here on our key on the right side, what we'll have is you'll have the 3-letter station identifier, so the nearest weather reporting location to the phenomenon. Then you'll have the report type. UA is routine. UUA is an urgent PIREP. Then you'll have the location, denoted by /OV. So this is in relation to a VOR. You'll have the time. FL will tell you the flight level or the altitude. Then you'll have the type of aircraft because you want to know if it's a Cessna 172 reporting extreme turbulence or a 737 reporting extreme turbulence, right? Then you'll have the sky cover, the weather type, the temperature, the wind, the turbulence, the icing, and the remarks. Okay, so let's read a few. So right here, we have our PIREP from BCE. So that's the reporting station. UA means it's a routine PIREP over the BCE VOR on the 180-degree radial 30 miles away. So that's how you read that. The 180-degree radial 30 miles away. So they're 30 miles to the south of BCE. The time was 12:43 Zulu. Flight level 360, so 30, about 36,000 feet. Type Boeing 737. They're reporting turbulence light to moderate chop. This one down here. So we have Bismarck, routine PIREP. They're over Bismarck. Time is 11:10. Flight level 170, 17,000 feet. Type CRJ 200. Uh, they are saying the temperature is unknown. Icing is negligible below 17,000 feet. So they're not picking up any ice. Down here, we've got SRQ Sarasota routine over Sarasota on the 320 radial 2 miles. So they're 2 miles to the northwest of Sarasota. Time 1300. Flight level 008, which is 800 feet. Type Beech 39 Musketeer. I don't know. It's a small aircraft. Sky broken 800. Weather light rain. So the clouds are broken 800 and the weather is light rain. Down here, we've got Knoxville, UUA. So this is an urgent PIREP. They're over the volunteer VOR on the 172 radial, 17 miles. So they're about 17 miles south of the volunteer VOR. Time is 12:53 Zulu. Flight level 080, which is 8,000 feet. Remember, add two zeros on the end. Type Beech King Air 350. Turbulence extreme. Turbulence 080 to 090, so between 8,000 and 9,000 feet. The remarks. DURD stands for during descent. Okay, so they got this turbulence during descent. If you see DURC, that's during climb. During descent, no injuries or damage. Okay, so probably don't want to be flying near Knoxville today. Winds and temps aloft here. It's an estimation of wind direction related to true north and wind speed in knots. So these are forecasted here. They send up weather balloons and they uh, will get this data and also use it to forecast. They're usually forecasted for 9 levels between 3,000 and 39,000 feet MSL, and it does not include winds within 1,500 feet of the station, and temps not forecast for any level within 2,500 feet of the station. So how this is going to work, the first two numbers are the true direction of the wind. So in this example right here, 2535, just focus on 2535. 25, the first two numbers is the direction of the winds. The wind is from 250. The second two numbers are the speed, 35 knots. Okay, the last two numbers are the temperature. So in this case, -08 is -8 degrees Celsius. If you get 9900, that means the wind is light and variable, less than 5 knots. For wind speed above 100 knots, you have to subtract 50 to the wind direction and add 100 to the wind speed. So if you see something like 7701, what we have to do is subtract 50 from 77, which gives us 27. So the wind at 270, and we have to add 100 to 01. So the wind is 270 at 101. So if we use this example, 6258, try to do that real quick. You need to subtract 50 from 62 and then add 100 to 58. So you're going to get 120 at 158. So the wind is at 120 at 158. This is what it looks like. The winds aloft chart looks like. So what you're going to do is go down to the area that you're in. So Amarillo, Denver, that's Kansas City, and St. Louis. So let's say we're at 12,000 feet in St. Louis. So our wind is 230 at 39 knots and -4 degrees at 12,000 feet. Remember, always read your notes. What does it say? Temps negative above 24,000. So above 24,000, so up here at 30,000, they just put all the numbers together. So the wind up here at 30,000 is at 230 at 94 knots and it's -40 degrees. If you hop over here to 34,000, look at this, 73. Okay, so now if you get a number, if one of the first two numbers is going to be over 36, right? So if you have 40, 45, 73 in this case, that means you're going to have to subtract 50. That means this wind is over 100 knots. So 73 minus 50 is going to be 23, right? So the wind is at 230, and then we have to add 100 to 06. So 230 at 106, and it's -49 degrees. So take a look right here at 39,000 at St. Louis and try to do this one real quick. Okay, so this is telling us we have to subtract 50 from 73, so that's going to be 230. And 19, so we have to add 100 to that, add 119, and all the temps above 240 are negative. So we've got 230 at 119 and negative 60 degrees. Moving on, we've got what's called air mets. Air mets are stand for Airman's Meteorological Information. What these are, there are three types, are just three separate ways for them to communicate weather in a general area to us. The three types are going to be airmet, sigmet, and convective sigmet. Starting off with the airmet, airmets are conditions that affect the operation of all aircraft, but they're primarily hazardous to light aircraft. They are valid for 6 hours, and there's three separate types. We have Zulu, Tango, and Sierra. So a Zulu is going to be an airmet released for up to moderate icing, and they'll include the freezing levels in that airmet. Tango is going to be up to moderate turbulence and or sustained surface winds of 30 knots or more. And then Sierra is going to be released for IFR conditions impacting more than 50 nautical miles of a defined area and or mountain obscuration. So if the mountains are obscured by clouds or such, you'll get a Sierra airmet. This is what they look like when you read the textual version on ForeFlight specifically. This one says mountains obscured by precipitation, clouds, and mist. This one right here, ceiling below 1,000, visibility below 3 statute miles, smoke and haze. Signets. Signets are significant weather not associated with convective activity. So this is going to be severe icing, not associated with convective activity, extreme turbulence, not associated with the convective activity, clear air turbulence, dust storms, sandstorms, and volcanic ash. These are going to be valid for 4 hours. Convective signets are going to be weather associated with thunderstorms. They always imply severe or greater turbulence, severe icing, low level wind shear. So these are not specified in the report. These can be issued for tornadoes, lines of thunderstorms, embedded thunderstorms, thunderstorms over a wide area, hail greater than 0.75 inches in diameter, and wind gusts above 50 knots. And these are valid for 2 hours. Surface analysis chart. So a surface analysis chart shows weather conditions as of the valid time of the chart. It shows locations of the high and low pressure systems and associated charts. The chart is transmitted every 3 hours. This is what a surface analysis chart looks like. Here's your key. Okay. The main things that you need to know is you need to know these little red lines, which are called the isobars, right? We talked about those last week. Isobars group alike areas of pressure, showing us how the pressure is changing in an area. Remember, right here, let's look over by San Francisco. You see these isobars are spaced closely together as compared to out here. When the isobars are spaced closely together, that means that there is what's called a steep pressure gradient, or the pressure is changing rapidly over a short distance. That's going to result in windy conditions. Okay, so you need to know what the isobars are. This L stands for low pressure. You need to know that. You need to know the different types of fronts on here. So this section right here in Minnesota, excuse me, is a cold front. You have a stationary front here. We don't have any warm fronts out here, but a warm front is just the red, right? And then you also really need to know the troughs, which are these orange lines. Those are going to be the most common things you're going to see on these. We're not going to pull up and look at a surface analysis chart when we're trying to decide if we're going to go do a training flight most of the time, right? Because we're going to use things like the METAR and the TAF to try to determine if we're just doing a local flight, what weather is going to be occurring. But for if we were going to do like a long cross-country flight in our 172, we're going to go from Columbus to LA. That's going to take multiple days, right? So we will look at the surface analysis chart to try to get an idea of how the weather is going to be behaving for the next few days, right? we'll look and see, oh, there's high pressure in Colorado right here, and low pressure in a stationary front. So the weather's probably not going to be great right here along the stationary front. And we've got this cold front bearing down on us from the west, which means we're probably going to see some bad weather in like Omaha over here. That's how you're going to use this. Okay. Weather depiction chart. This provides an overview of weather conditions at the time. Basically, this takes METARs and puts them into a version where you can look at all of them at the same time. Okay, this comes out every 3 hours. This is the key for it. Take a picture of this and study this. There's not really anything for me to teach you besides you looking at this. Okay. Radar summary chart. So this is computer generated radar summary produced each hour, 35 minutes after the hour. It is limited to only detecting precipitation. So it can only detect precipitation. It's not telling you what type of precipitation um, or the winds or anything besides if there's precipitation. It can tell you, um, based on the contour, what level of radar return they're getting. The higher level of radar return, the greater the rain is going to be in that area. Okay. You need to know, or important to know, is the difference between NE and NA. So no echo versus not available. No echo means that the radar investigated that region and received no echo. There's no precipitation. Not available means that the radar could not investigate that area, so they don't know if there's precipitation there or not. These underlying numbers here are going to tell you the echo tops in hundreds of feet. So right here, this echo tops at 55,000 feet. So that's a really tall storm there off the coast of Florida. And then these arrows with numbers tell you the speed and the direction in which the echoes are traveling. So this is 12 knots to the east. Prognostic charts are next. This is a low-level chart that's valid from the surface to 24,000 feet. It's designed to help with avoiding low-vis ceilings, turbulence, and ice. They're issued 4 times a day with a valid print time on the lower margin of each panel. The two panels on the left indicate weather 12 hours ahead, and the panels on the right indicate weather 24 hours ahead. There's not much for me to teach you here either, just because all these charts have the key in the middle of them. So right here is the key. So if you want to know what something means, you're just going to look at the legend. Okay? I have faith in you to be able to do that. You will see these on the written. They will probably ask you about this. Here's the convective outlook chart. So this is a 48-hour forecast for thunderstorm activity. It's issued 5 times daily. All it's doing, it's telling you the likelihood of a thunderstorm in each area. And you can look down here at the legend and find out how likely it is. Winds aloft chart. So winds aloft chart are 12 hours forecast that are valid at 0 Zulu and 1200 Zulu. The predicted winds are shown by arrows emanating from the station circle to the nearest 10 degrees. So how to read these, because you will actually encounter these quite a lot, um, goes like this. Let's look at this one right in central Iowa, right here. So the wind is coming from the west, blowing to the east, right, this way. Uh, and each one of these flags, the long ones are 10 knots. The short ones are 5 knots. So this right here is 5, 10, 25. So it's a 25 mile per hour wind from the west. This one is a 20 mile per hour wind from the west. If you see a flag, that's 50 knots. So right here, the wind is 50 knots from the southwest. These are good for getting an idea of just the general wind patterns over a general area. And you can, when you use these, it's like a tool and it's a shader. So you'll move it up and down based on the altitude in which you want to look at. So you can look at 20,000 feet, 15,000 feet, 8,000 feet, whatever, or the surface. That's it for today.